Suppose the x coordinate of a particle as a function of time is 4 cos 6t. A particle moving in the xy plane, its x coordinate as a function of time is 4 cos 6t. The y coordinate as a function of time is 4 into, say, 1 minus sine 6t. Right? Now, I want to find the distance traversed by this particle. I want to find the distance traversed. I want to find the distance traversed in, say, 5 seconds. I want to find the distance traversed by the particle starting from t equal to 0 in 5 seconds. Not the displacement, but the distance. The x and y coordinates are known as a function of time. So, can I find the velocity component in the x direction as a function of time? How do I do that? dx dt. dx dt. If I differentiate x with respect to time, I get this. And by this time you would have realized that if I differentiate with respect to time, 4 cos t, what would I get? Minus 24 sine 6t. All of you understand this? Differentiating with respect to time, chain rule? Chain rule. Velocity in the y direction is a rate of change of y with time, which is d dt of 4 into 1 minus sine 6t. So this one is a this 4 will come out, and d dt of 1 minus sine 6t, which is 4 into 6, so minus 24 cos 6t. That's the velocity. So velocity in the x direction is varying with time. Velocity in the y direction is varying with time. Yes or no? If I square and add vx squared plus vy squared, would I not get 24 squared? 24 squared into sine square theta plus cos square theta, which is 1. So will I not get 24 squared? And this will give me square of the magnitude of the velocity. It will give me square of the magnitude of the velocity. Vx square plus vy square will give me square of the magnitude of the velocity. V then will remain 24 meters per second. That means the magnitude of the velocity is not changing. This is a case where Vx and Vy are changing with time, but the magnitude of the velocity remains 24. The magnitude of the velocity is called speed. That means the speed is not changing with time. The speed is not changing with time. Therefore, if the particle has a constant speed, then the distance will be speed into time. If the no matter what the trajectory is, if the speed is remaining constant, no matter what, if this is my trajectory, complicated trajectory, but if the speed is remaining v at all times, then the distance along the trajectory in t seconds, will always be v into t. So v is 24 and t is 5. So 120 meters is the distance covered by the particle. 120 meters is the distance covered by the particle. Yes or no? 120 meters will be the distance covered by the particle. So understand this. No matter what the trajectory is, if the speed is not changing with time, velocity may be changing. In this case, velocity is changing because the direction is changing, right? But the speed is remaining the same. So the distance along the trajectory will always be speed into time, and speed is remaining constant. Speed is remaining constant. So 120 meters would be the distance covered along the trajectory. How about it, right?